Yours truly, Professor Dr. Dolphy Gilpin, and we are continuing with plutonium here. And this is a partial view of the periodic table that contains plutonium in the actinide period of period 7. Pu, atomic number 94, atomic mass or weight of 231. Plutonium, actinide series, period 7, with an electronic configuration of 5f67s2, something like that. We will certify that, or 5f37x2, 7s2. We'll solidify that plutonium. And let's continue with our presentation of plutonium here. Okay, let's continue with our final portion of plutonium. Plutonium, the electron configuration of radium, are in 5f67s2. 5f67s2. Radon 5f67s2. Okay. Where did we reach with this? We have reached our last 2 pages here. Now, plutonium metal is a yellow or olive green. We have said this over again. And when ultraviolet light is shined onto it, it turns into and become red. So that's plutonium. When ultraviolet light is focused on it, it becomes red. But normally it's a yellowish metal or olive green metal. When plutonium comes in contact with other radioactive elements, it sends out a dazzling blue light. So in the presence of other radioactive elements, plutonium sends out a dazzling blue light. Plutonium decays to uranium-238 via alpha decay, and it will also decay by spontaneous fission. And there's an hydride catalyzed reaction of plutonium in water. The reactive hydride reacts with more water and form plutonium oxide hydride, or the plutonium oxide, and regenerate hydrogen, which propagate continued reactions. Now, plutonium metal readily dissolves in concentrated hydrochloric acid and hydroiodic acid, as well as perchloric acid. It readily dissolves in concentrated hydrochloric acid, hydroiodic acid, and perchloric acid. And a relatively large piece of plutonium is warm enough to the touch because of alpha decay. And the energy liberated by a more substantial amount of plutonium in the atom is able to cause water to boil. Reaction: plutonium plus carbon give you plutonium carbide. Plutonium plus nitrogen give you plutonium nitride. Plutonium plus silicon give you plutonium silicon. That is Pu plus 2Si give you Pu Si2. And plutonium 3 plus and plutonium 4 plus are important oxalates that form oxides. As a step in plutonium processing. So plutonium 3 plus and plutonium 4 plus oxidizing states are important oxalates that will form oxide as a step in the plutonium processing. Now, other important compounds in reprocessing are the fluorides, plutonium fluorides, the plutonium peroxides, and the catalyzed acetyl acetone, and the carbonate, as well as the hydroxide. We have PuF3, which is plutonium 3 fluoride, and PuO2, plutonium oxide, Pu2O2 or PuO2, plutonium peroxide. So there we have an introduction to plutonium, and plutonium atomic number 94, atomic mass 231. There's also a lot of isotopes of plutonium there. I think these are one with a weight of 244, the one with a plutonium 239, and the electronic configuration of radon 5f67s2. It doesn't have any d orbital or d shell in the electronic configuration there. 5f67s2. So that's plutonium introduction there. And let's show the Professor Dr. Dolphy Gilpin in closing here. We'll, because of this dominant negative usage of plutonium in nuclear bombs and things like that, I think there were more negatives that, in the plutonium reaction than positive. I will be spelling peace via chemical elements. And this will be my next step. I'll be spelling peace with my chemical elements here. So the word peace, let's take another session for this.